Okay, so in this video, we're going to cover plotting in Python, my personal favorite. And the way to get started with plotting in Python, plotting data in Python, plotting functions in Python is with the pyplot module, which you can access through the package matplotlib. Okay, this module is based off of MATLAB. So if you're familiar with MATLAB plotting, this should come easy. And how does it work? Well, if you have an array of X values and an array of Y values, and these can be lists, these can be NumPy series objects, or they can be, not NumPy, these can be Panda series objects, or these can be NumPy ND arrays, or they can be lists, anything that has the same number of elements in them and are numerical. So we just pass in our X values and pass in our Y values, and then we're going to get a nice looking plot that will be shown to us. So in this case, I first import matplotlib.pyplot with the alias PLT, which is the convention. I also import NumPy as NP. I define a quick function here called squared, which just takes in a value of X and then squares it. I make a small ND array with 5 entries in it. And then for the variable Y, I just square each of those entries. Now, calling a function on a list in Python won't work. I'm calling a function on an ND array. That does work. Okay, so this is one way of doing it. I print out those values, and then I call the plot method from pyplot, and then I call plt.show. So this show method, and this is what you would do in something like a VS Code. So I include it here as well. All right, so let's just go ahead and copy this and then run it. And we immediately have a figure representing the square of the X values that appear in this ND array. However, it's kind of small, and I would like to adjust the figure size. So I'm going to repeat everything, and I have to mention this. I'm repeating the code over again. Like, for example, I'm defining my function again, I'm defining X and Y again. I'm doing that over again so that each cell is self-contained. Basically, up here, you import your modules, but other than that, you can just run the code here in the cell below it, and it will work. Sometimes when you look at or you clone repositories from like online and you try to run the cells, they don't work without having to do some extra step. I like to keep all the code self-contained, but you don't have to do that. So I could completely ignore, like, I'll just show you. I'll just do this right here without running what's above, and it will work. Okay. So the figure is bigger, and that's because I call the figure method before calling plot, and I set inside that the keyword fig size equal to the dimensions 10 by 8. So we have a nice big plot in front of us. But there's no labeling on the axis, the x-axis and the y-axis, and there's no title. Anytime you're presenting a figure to anyone, you need to definitely label the axes. So we can do that using the methods xlabel and ylabel.
Sorry, Professor?
Yes.
How did you choose 10 by 8?
That's just what I'm used to picking. You can pick whatever you want. For example,
does it depend on the numbers, like
no,
the scale? Oh,
no,
okay.
it depends on the size of the figure in front of you.
Okay.
Right. So, for example, if I get rid of this plot method right here, I guess there has to be something there, but so generally speaking, when you're plotting data in Python and in Julia, you're stacking together a bunch of method or function calls over and over again on top of each other. So what this figure method is doing is it's saying before anything else is done that this is going to be the size of the figure that's appearing in front of you. Okay, and then on top of that blank figure, I then call the plot method, which strings together these values. which is, that reminds me, I should probably tell you what's happening here. There, for each of the pairs of numbers in here, for example, 0, 0, that appears as a point right here. And then there's another point, 0.5, 0.25, that appears right here. There's another point, 1, 1, that appears right here. There's another point, 1.5, 2.25. So that appears up here. And the plot method is sequentially, so there's an ordering to this. The ordering does matter. It's going from the first point to the next point, to the next point, to the next point. And it's drawing a line between them. So this is the square of the x values. And you can see that it's choppy, right? It's because it's stringing together these points, and there's only 4 of them, or 5 of them, right? So 1, 2, 3, 4, 5. So that's how this line is being drawn. And we'll talk about this more in a moment. So as I was just mentioning before that, we need to add the labels for the x-axis, the y-axis. We should probably give it a title, and then maybe give a legend as well, describing what this line is telling us. And we can do that using these methods. To give the x-axis a label, we call the method xLabel, y-axis ylabel. To give a title, call the title method. And then to provide a legend, we call the legend method. Okay. So as before, I don't need to define my function again. I don't need to define x and y again. I can just run the code from here down. Okay. So let's run it and talk about what happens. So we see that on the x-axis, we have time in seconds, y-axis, distance in meters, and then the legend says that the blue line is f of x equals to x squared, and then the title is my first plot. Notice that my first plot is bigger, the title is bigger, the font size is bigger than the font size for the x, y axis and the legend. That's because when I called the plt.title method, I gave the string to which will appear, but then I gave a keyword font size equal to 15. So hopefully you can guess how to make these labels bigger, the font bigger. So for example, if I wanted to have a bigger font size for legend, I could say font size equal to 13, shift enter. And now I see that my legend font is bigger. If I wanted to make the X and Y font size bigger, I do the same thing. Just come up here to those methods. And then same for the X. Now I have larger font size on my legends. So this is a line plot. Next up are scatter plots. And this is really simple. As I mentioned before, the line plot is created by sequentially connecting the points created by X and Y in the Euclidean plane. So it's connecting these points with a line. But we can just view those points on their own by, instead of calling the plot method, call the scatter method. So let's see what happens when we do this. So this is the only difference. Instead of plot, I'm doing scatter. Well, there's actually one more difference, and I'll see what that is in a moment. Right, so we have points, and now they're red, right? Oh, I almost forgot. So inside of the scatter method, I said color is equal to red. That's a keyword argument. But I also said label is equal to points. Okay. Now above, I forgot to mention that when the legend appears, I didn't give the legend any keywords to say what should appear there. That happened when I called the plot function, and inside of that function, I gave the keyword argument label. So when you plot or scatter data, you can assign a label, and then when you call the legend method, you can specify keywords like font size or whatever. There's all sorts of things, or position. That's like another example. But the labels that you attach to the plot or scatter will automatically appear in the legend. So that's why it says f of x equals to x squared right there. And that's why down here, it says points. Okay, and whatever you type in here is going to appear there. So red points, and I run that, it says red points now.
Would you
So-
be able to add more labels? Is there another way to, if you wanted to do blue points, red points, etc.?
Yes, and we'll get to that in a bit. So that on that note, this is similar to overlaying different plots. So again, I don't have to run this again up here, but I want to, for example, overlay these red dots with the blue line that we had earlier. So the way to do this is in this layering fashion that I mentioned earlier. You have a blank figure that you start with of this size. And then on that figure, I'm going to plot and look at the keyword. So I'm specifying the label, that's the same. But now I'm going to say that I want the color of that line to be green. And then I'm also saying that the line style is going to be whatever this is. In the description of this video below, when I post this to YouTube, I'll give you links to all the possible colors and all the possible line styles to choose from so that you can play around with this. But that's what's happening. I'm putting that line on there. And then immediately underneath that, I'm scattering. So I'm scattering on top of the line that was previously put onto that blank figure. Next up, I'm setting the label for the x-axis. I'm setting the label for the y-axis. I'm saying that there's going to be a grid. I'm putting my legend, making my title, and then I'm showing. So let's go ahead and see what happens when we run this code. You can probably guess what's going to happen. So calling the grid method made these lines appear on the x ticks and the y ticks. That's what those are called. And we can see that we have our green line and then we have our red dots over each point. And the green line is dashed. Okay. And notice that the legend, we have two different labels. We have the green line and then the red dots. And that looks a little bit small. So you know that you should change this maybe by saying something like font size equal to 13 or whatever. Make it bigger so that it's easier to read. Okay. So next up, I have a simple yet intricate and nice plot. So I'm going to copy all of this and I'm just going to talk you through what's happening. I just want to show you the output. So here's the output. This is a nice looking plot to me. I like it. I see that, look at the X ticks. I see the actual symbol pi, right? From 0 to 2 pi, I have, looks like these are, oh, the legend tells me sine and cosine. So going back up to the code, what's happening? So I see here, this is NumPy. And this looks like a linspace method. So what you should do when you see this, if I wasn't describing it to you, you should go and look at the attributes of the linspace method on NumPy documentation, right? So what it's doing though is going from 0 to 2 times, oh, there's another NumPy thing, numpy.py. You can probably guess what that is. So 0 to 2 pi, and I want 100 elements equally spaced in that interval. So it's making, in a sense, like a domain for my functions. And then here, special X, well, this is a small list. It's a list, not a NumPy array. 0, pi divided by 2, pi, 3/2 of pi, and then 2 pi. So in that list, okay, I set my figure size. And then on top of that, I plot X, which is the linspace X, and then sine applied to that. I give it the label of sine, color green, and make it dashed. Next, on top of that, I scatter. I scatter as X values 0, pi over 2, pi, 3/2 of pi, 2 pi. And then for the Y values, I apply sine to each of those values. So there's only 1, 2, 3, 4, 5 points. So there should be 4 dots. Okay. And maybe I can even change the color and say, change the color. You can see the dots change to light sea green. It's one of my favorite colors to use. And then after I scatter those points, those special points, I then plot the same linspace x, and now cosine applied to that. I give it the label of cosine, give it the color of magenta, line style solid. I didn't have to give, I could get rid of this by just doing the little pound symbol, and it should still appear the same. Okay. And then after that, I scatter those special values of x, and then cosine applied to those special values. I set the grid, and then here, you haven't seen this before, I'm calling the xticks method. So what I'm passing in here are those 5 special values of x, and then I have a list of the labels. So this is a keyword now because you see the equal sign. The 0th entry of special x, I will assign the label of 0. The 1 entry, I will assign the label of this. Notice inside the strings, I have the dollar signs. This is indicating that I'm going to use LaTeX configuration. So if you've ever used LaTeX before, to get pi, you do \pi. So inside of the LaTeX block right here, \pi, it's going to convert that to look like pi. Same thing here, LaTeX pi, 3 times LaTeX pi divided by 2, 2 times LaTeX pi, all in strings. So each of those entries in special x will now appear as the xticks, and the symbol that will appear in place of the numerical value will be these strings. And then I set the font size. Set my Y label, legend, title, show. And that's what gives me this. Okay. So I encourage you to work through this notebook on your own and play with changing things and just get used to making the graphs look the way that you want them to with these simple functions. Okay, so that will conclude our video crash course Python, or our crash course Python video on using matplotlib to generate simple line plots and scatter plots. Okay.